Hi, my name is Varun Parekh,
And I'm Dheer.
and welcome to our CS484 final video project. For the agenda, we have a background, research problem, and motivation, as well as our current approach and the current status of our project and the takeaways that we got so far. So for the background, a national veterans organization often relies on mail-in fundraising to help support their programs and services to help affected veterans. However, like many companies, they also suffer from a high amount of non-responsive people. Lapsed donors are considered those who haven't donated in over a year, so essentially there's no point in sending them any more requests as it's a futile effort. The goal of or research problem is to figure out a set of models in which we can best evaluate whether or not a person would be willing to donate in the future. The reason we chose this project is because it's very interesting to research how non-responsive bias works and can affect futures donations.
So this is our current approach. To read and visualize the data, we're currently using NumPy, Pandas, and Matplotlib for graphs. And for this particular experiment, selecting between various models, we're exclusively using models offered by sklearn. This is so to make sure we have a more controlled experiment. And for data processing, our approach is using one-hot encoder to transform categorical data to numerical data. And we're also using lasso regression for feature selection, especially because our features in this particular data set are really large. And we're also on top of lasso regression using PCA or UMAP for feature reduction. And we're experimenting between both of those to see which one works better. And also min-max scaler to appropriately scale the data, especially because our data dimension in this data set is 481. And we've also tried using predefined pandas methods to handle categorical data. So these are our current selected models and the models that we've been experimenting with. They include logistic regression, random forests, extra trees, decision trees, gradient boost, ADA boost, K nearest neighbors, MLP, SVM, and naive Bayes.
Currently, we have successfully run the dataset and tested each model as of now. To zone in on the optimal set of hyperparameters, we employed the use of random search by sklearn. Currently, the accuracy is roughly the same throughout every model, with the real fluctuations occurring between the F1 scores and the area under the curve. As you can see, with the area under the curve ranging between 0.5 and 0.63, and the F1 score being all over the place. So as for current issues with our project, due to the vast size of the dataset and many inconsistencies like class imbalances and missing values, categorical values, and great dimensionality, these are the reasons why the scores are averaging around 50%. Data preprocessing needs to be improved using SMOTE and a better feature selection like recursive feature elimination. Having not fully finalized the final set of hyperparameters to use on each model is another affecting issue that we're having to deal with. But the most biggest issue of all is 95% of the values in the dataset itself are of the same class, which are leading to overfitting issues causing errors in classification.
So these are some takeaways and next steps that we look forward for our project. So we intend to further pre-process data by using SMOTE from libraries like IMBlearn, just like Bart mentioned earlier. And by using SMOTE, we intend to handle the huge class imbalances in order to create a more effective training set for the models to be trained on. And we're also planning on using recursive feature selection for feature selection instead of lasso regression, the one we implemented currently. Or we're also planning on experimenting with only dimension reduction like PCR UMAP for better feature selection. And we're also going to use a combination of grid search or random search or one of those to decide on the final approach for finding the most optimal hyperparameters. And simple routes like using predefined functions like from pandas are fast, but often result in undesirable results. So we're planning on sticking to using specialized libraries to handle pre-processing like sklearn and IMBlearn. And we also intend to implement cross-validation to accurately choose the top models that reflect the best scores in their regarding metrics. Thank you.
Thank you for watching.